Natural numbers. All positive integers are natural numbers. Example 1, 2, 3, 4, 8 and so on. There are infinite natural numbers and number 1 is the least natural number. Classification of natural numbers. Based on divisibility, there would be two types of natural numbers. They are prime and composite. Prime number. A natural number larger than unity is a prime number if it does not have other divisors except for itself and unity. Note that unity, that is 1, is not a prime number. The properties of prime numbers are: the lowest prime number is 2. 2 is also the only even prime number. The lowest odd prime number is 3. For prime numbers p greater than 3, p square minus 1 is divisible by 24. If a and b are any two odd primes, then a square minus b square is composite. Also, a square plus b square is composite. The remainder of the division of square of a prime number p greater than or equal to 5 divided by 12 is 1. Let's see the process to check if a number is prime or not. Take the square root of the number, round the square root to the next highest integer. Call this number as z. Check for divisibility of the number n by all prime numbers below z. If there is no number below the value of z which divides n, then the number will be prime. Composite numbers are the numbers which are not prime. They are also called coprimes. Two numbers a and b are said to be coprimes if their HCF is 1. Now I am going to explain what a place value is and what is face value of a number. Let's consider this number as an example. Here, the place value of 2 can be found out by multiplying 2 with unity as it is at unity. Similarly, the place value of 5 is the product of 5 with 1000 as it is located at the thousands place. Face value is the value of the digit itself at whatever place it might be. Hence, in this example, face value of 2 is 2, face value of 3 is 3, and so on. There are some rules to find out the divisibility of a number by certain numbers. Divisibility by 2. A number is divisible by 2 if it is an even number. Divisibility by 3. A number is divisible by 3 if the sum of its digits is divisible by 3. Example: 5,92,482 is divisible by 3, since sum of its digits is 30, which is divisible by 3. Similarly, 8,64,329 is not divisible by 3, since sum of its digits is 32, which is not divisible by 3. Divisibility by 4. A number is divisible by 4 if the number formed by last two digits is divisible by 4. Example: 8,92,648 is divisible by 4 since the number formed by the last two digits, which is 48, is divisible by 4. Similarly, 7,49,282 is not divisible by 4, since the number formed by the last two digits is 82, which is not divisible by 4. Divisibility by 5. A number is divisible by 5 if its units digit is either 0 or 5. For example, 20,820, 50,345, etc. Divisibility by 6. If the number is divisible by both 2 and 3, then the number is divisible by 6. For example, 35,256 is clearly divisible by 2, and the sum of these digits is divisible by 3. Thus, the given number is divisible by 6. Divisibility by 8. A number is divisible by 8 if the last three digits of the number are divisible by 8. Divisibility by 11. The difference of the sum of the digits in the odd places and the sum of the digits in the even places is 0 or divisible by 11, then the number is divisible by 11. For example, 48,32,718. Here, the difference of the sum of the digits in odd places and the sum of the digits in even places is 11, which is divisible by 11. Hence, the number is divisible by 11. Divisibility by 12. All numbers divisible by 3 and 4 are divisible by 12. Divisibility by 7, 11 and 13. If the difference of the number of its thousands and the remainder of its division by 1000 is divisible by 7, 11 and 13, then the number is divisible by 7, 11 and 13. Division algorithm. If we divide a number by another number, then dividend is equal to sum of remainder and the product of divisor and quotient. There are some shortcuts for multiplication. Let's go through them. Multiplication by distributive law. A into B plus C is equal to AB plus AC, and A into B minus C is equal to AB minus AC. Example. In these examples, using the distributive law makes the calculation simpler and faster. If a number is multiplied by a raised to n, we need to put n zeros to the right of the multiplicand and divide the number so formed by 2 raised to n. This simplifies the multiplication with the numbers in the form of a raised to n. Here is an example. Series and progression. A succession of numbers formed and arranged in a definite order according to a certain definite rule is called a progression. There are two types of progression: arithmetic progression and geometric progression. Arithmetic progression. If each term of a progression differs from its preceding term by a constant, it is called arithmetic progression. This constant difference is called the common difference of the arithmetic progression. The nth arithmetic progression is given by the formula shown on the screen. The sum of n terms of arithmetic progression is given by the formula shown on the screen. Some important rules in arithmetic progression are: sum of n natural numbers is given by half of the product of n and n plus 1. Sum of squares of natural numbers is given by 1/6 of the product of n plus 1 and 2n plus 1. Sum of cubes of n natural numbers is given by the sequence of half of the product of n and n plus 1. Geometric progression. A progression of numbers in which every term bears a constant ratio with its preceding term. The nth term of geometric progression is given by this formula. Sum of n terms of geometric progression is given by the formula shown on the screen.